Hello, in this video, we're going to go over number 9 from the 8.3 homework. The question code is 8.3.5-T. It says, use technology to find the p-value for the hypothesis test described below. The claim is that for a smartphone carrier's data speeds at airports, the mean is mu equals 19 megabytes per second. The sample size is n equals 22, and the test statistic is t equals negative 1.362. You can see here that I've written what we know for the problem. We know n is 22. We know our test statistic is a t value, and we have t equals negative 1.362. Our claim is mu is 19. So because we know our claim, we can write our null hypothesis, which is also mu equals 19, and our alternative hypothesis, which would be mu is not equal to 19. So this will result, because we have a not equal to sign here, we have a two-tail test. On our two-tail test, we came up with a t is negative 1.362. Actually, that's given to us. When we calculate our p-value, we're going to go from some really negative number all the way up to negative 1.362. And we're going to get this shaded area right here. That will only be half of the p-value since you have a two-tailed test. So once we find that area, we're going to double it to get our final answer for the p-value. Let's do that using our calculator. In our calculator, press second vars, and we're going to go down to TCDF. On some of our calculators, it might be number 5. On some, it's number 6. On this calculator, it's the number 6. So your lower limit needs to be at least 4 standard deviations out, so a minimum of negative 4. I already have negative 1 times 10 to the 99th. That's a really low number. And then for your upper limit, you're going to put negative 1.362. Negative 1.362. And our degrees of freedom for this problem, well, that's just n minus 1. And our n is 22. So 22 minus 1 is 21. And then you will simply paste. Now, if you're a person who doesn't have a menu option on your calculator, you're going to type it in just like you see here. So you'll have your lower limit, a comma, which is above number 7, your upper limit, a comma, and then your degrees of freedom. Remember, degrees of freedom is your n value minus 1. And we come up with 0.0938. So we just found the circled shaded region as 0.0938, but remember the p-value is made up of both of these regions. So our p-value is going to be equal to 0.0938 times 2. When you multiply that by 2 and round to 3 decimal places, as asked for in the problem, you get 0.188. And remember, we only had to double this amount because we had a two-tailed test. If you had a left-tailed test or a right-tailed test, when you calculate the p-value, you will have covered all of the shaded regions. So you're just doubling that number when you have a two-tailed test. So 0.188 will be your answer. And remember, there are reference directions for doing a similar problem like this with a right tail on page 2 of your guided notes. Now, the only difference when you're on page 2 of your guided notes is that you might have a problem that does not have a right tail. Instead, it has a left tail or two tail, like I just demonstrated. But you're going to take care of that with your left limit and your right limit. So make sure you draw a diagram of the problem first so you know what limits you're working with. And then if it's a two-tailed test, you're going to double whatever answer you have. For right or left tail, you don't have to double that amount. I hope you found this helpful. Let me know if you have any more questions.